there was only one logical thing to do.
What is it?
I rented an entire island.
It's time for some more NileRed. Specifically making the stinkiest chemical known to man. Glad I can't smell this video. Those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's see.
Ever since I started this channel, I've been making stinky chemicals, and some of my favorites have been things like putrescine and cadaverine, which are supposed to smell like a rotting body. I've also made some other fun ones, like butyric acid, which smells like vomit, and I've even recreated a horrible mixture that was developed by the US government.
What's interesting is in nuclear engineering, most of what we deal with, such as uranium, plutonium, fission products, aren't particularly smelly at all. It's just hazardous because of the radiation and the chemical hazard. The smelliest stuff that we encounter are going to be on the chemical side of the nuclear fuel cycle.
All of these, though, are apparently nothing compared to something called trithioacetone, which is supposed to be the stinkiest chemical ever made.
Yeah, I've heard of that one.
Everything that I've read about it makes it sound absolutely horrible, and according to Wikipedia, it's actually considered a dangerous chemical due to its extremely foul odor and its ability to render people unconscious and induce vomiting.
Always important to point out your hazards on your material safety data sheet, even if they seem trivial compared to, say, burn hazards or radiation hazards or caustic, acidic. Don't underestimate stink.
What's also kind of concerning is that the smell itself has been described as just fearful, and it apparently has the ability to spread over large areas.
Smelling so bad that it inspires fear. Okay.
This was unfortunately experienced firsthand in 1889 when some scientists accidentally released a small amount of it. The horrible smell was then able to quickly spread out over a large area of the
panic
town,
evacuation.
and it caused people to faint and vomit, and it led to a panic evacuation.
Not just an evacuation, a panic evacuation. Within nuclear engineering, you look at emergency response procedures, which would include things like evacuations and shelter in place. Best thing to do is not to panic, though. So if something that just the smell by itself incites panic, that's terrifying, and it introduces a whole other set of hazards. Because what's interesting is when dealing with emergency response, sometimes an evacuation is not the conservative action because it can inspire fear, because it can incite fear, panic, and ultimately cause more harm than the actual natural disaster or nuclear accident, for instance. Not to say evacuation should never be used, but it's a decision that is not meant to be taken lightly, especially when you decide which zones to evacuate and which zones to shelter in place.
There are even some claims that diluting the smell makes it worse, and that it's possible to smell a drop of it downwind in seconds, even at a quarter mile away.
Wow. So what's interesting is, as I was saying earlier, is most nuclear hazards are going to be silent and odorless, whereas trithioacetone announces itself violently through the forms of extremely bad smell. So in a way, really bad radiation is, if it smelled this bad, people would at least know to avoid it. So in some cases, nuclear safety could actually be easier if it did smell.
Based on all of this, it really does sound like the worst smelling chemical ever, but I honestly just don't really believe it. Even though all of these claims
Sure, anecdotal stuff from the late 1800s.
Are coming from credible papers and reports, it just doesn't seem possible.
You just want to smell it, don't you?
That something could be that horrible. All of this made me really curious, though, and I just felt that I had to know what it smelled like and to experience the horror myself. Sadly, though, I couldn't find anywhere to buy it from, and it doesn't seem like anyone has made it in the last 60 years.
Not sure if the eyes watering like that are meant to show that he can't buy it, or the effects on the eyes as of getting a whiff of that from, I don't know, 10 miles away or something.
So, if I wanted to see if it was actually as bad as it's claimed to be, it was unfortunately looking like I only had one real option, and I was gonna have to make it myself.
Make it himself, possibly buy some single-use, ultra-expensive and specific equipment from China. Possibly.
But anyway, to get started, the first thing that I had to do was figure out how to even make it. So I went online and I did a bit of research.
I love how he researches it.
And it seemed to be relatively straightforward. From what I found, the typical method was to start with just regular acetone, convert that into something called trithioacetone, and then split that apart to release the supposedly terrifying thioacetone.
Like the phrasing of that, release it.
The only problem was that I couldn't find any real details on exactly how to do this, and I guess this makes sense.
Sounds like every NileRed video ever. Limited procedures, limited instructions, and he just figures it out. Gotta love it.
Because I don't think anyone actually ever makes it. However, I then noticed on...
Yeah, I'm trying to think of a situation. This is one hazardous chemical that we don't use at nuclear plants because it just doesn't have any use for it. If it showed up, we'd have to clear out the facility due to the extreme chemical stink hazard.
Wikipedia, that it mentioned the people who first discovered thioacetone.
Sure.
These were actually the same scientists who caused that disaster in 1889, and I figured if anyone knew how to make it, it would probably be them. So I just went back to Google, searched 1889 and their names, and their original paper was apparently the first result. I was honestly kind of shocked by how easy this was to find, except it took me way too long to realize that it was all in German.
Sure.
With Google Translate, though, I was hopeful that this wouldn't be a huge issue.
That can be challenging. Specific technical instructions from one language to the other. It's one thing to learn conversational German, but then there's directing nuclear power plant operations in Germany using very technical language, procedures, different behaviors of personnel, just with all the cross-cutting cultural, social, and non-verbal cues that you get when directing nuclear power plant operation. I mean, after all, it's much easier to say hello in German than average logarithmic energy decrement per fission in German for a non-native speaker.
And I just copy-pasted the part that I felt was important. The result that I got was actually surprisingly good, and I felt that it was more than enough for me to work with.
It'll get you in the right direction. Translating power plant procedures from one language to another is not as simple as cut and paste in Google Translate.
So now, with a decent idea of what to do, it was time to make the trithioacetone. Based on
I love it. Just very simple. Find out how to make it and then make it.
the procedure, it seemed relatively simple, and pretty much all I had to do was get some regular acetone and bubble some hydrogen sulfide gas through it.
Now, hydrogen sulfide is used in uranium processing, sometimes like converting uranium hexafluoride to uranium dioxide or during yellowcake processing. And this has some pretty bad smell to it. Say rotten eggs times 10, and the smell is definitely noticeable in parts per billion concentration.
This alone normally wouldn't have been too bad, but I apparently had to do it for 10 to 12 hours, which kind of disturbed me. This is because hydrogen sulfide is almost just as toxic as cyanide,
There's a reason why it doesn't smell good.
and 10 to 12 hours meant that I was going to have to make a lot of it. The only somewhat good part is that making it is relatively easy, and to get started, I just needed a bunch of powdered iron and some sulfur. What I had to do next was just mix these together, so I dumped a bunch of the sulfur into a container, along with some of the powdered iron.
Even sulfur by itself doesn't smell great.
I then quickly sealed it by screwing on the lid, and I started shaking it around. I had to do this until it looked like one uniform color, and after a few minutes, I felt that it was looking pretty good. So I went and got a lid of a paint
Shake
can,
and bake.
and I carefully poured out a bunch of it. I then did my best to spread it out a bit and clean it up, and now it was time for the fun part. To get things going,
Nice.
all I had to do was blast a glass rod with a blowtorch and then carefully touch the mixture. Normally, this would almost immediately trigger a reaction, except for some reason, it kind of didn't do anything.
But yeah, this is a bit like trying to enrich the uranium hexafluoride in your basement. Technically doable, but could get a lot of nasty gas in there with one bad valve turn. Needless to say, at actual processing facilities, there's rooms dedicated to this with proper filtering and ventilation and emergency procedures, which would include evacuation, hazmat cleanup, incident response. Yeah.
This made me a bit worried that my eBay sulfur and iron were bad or something, but that thankfully wasn't the case.
There you go.
They finally started reacting together and combining to form something called iron sulfide,
That's
and it was
satisfying to
also
watch.
letting off a lot of heat. Over the years, I've actually done this
Exothermic.
reaction many times, and it has always been one of my favorites. The last time I did it on a large scale like this was when I made my own glow toys a few years ago, and I don't think I'll ever get tired of it. It's just kind of mesmerizing, and I really like the sound that it makes. After a while, though, the reaction was eventually done, but it was still extremely hot, and I had to wait for it to cool down. When I came back to it about 30 minutes later, it was looking pretty good. Now, all I had to do was separate this crusty stuff from the lid, and it was surprisingly easy. I then started crushing it and breaking it into smaller pieces, and that was about it. What I had now was a bunch of iron sulfide powder, which is kind of a stored form of the scary hydrogen sulfide gas. To actually turn this into the gas, though, I'd have to put together a little gas generator, so I dumped it all into a flask. After that, I took away the funnel, cleaned up the joints using some paper towel, and started putting together the rest of the setup. To do this, I added a stopper, an addition funnel, and an outlet for the hydrogen sulfide to leave the flask. At this point, the scary generator was more or less ready,
generator.
and it was time to put together the rest of the setup.
Go.
So I went and got another little flask, and into it, I added some acetone. I had no idea how much I was supposed to be using, though, and I just randomly decided on 15 milliliters. Then on top of this,
Again, I know this gets me every time whenever he's just like, yeah, I'm not really sure. I'm just going to kind of wing it when dealing with these sorts of materials here and the associated hazards when used to procedures, and not only by, and by the way, these procedures wouldn't just be looked at by, say, the chemistry expert or the chemistry technicians or subject matter experts within one department. Safety personnel would look at it, operations personnel would look at it, basically anyone with a stake that could possibly be affected by performance of this operation if you were at a nuclear plant, or really any facility for that matter. And it would discuss, and probably for something like this, at least half of the verbiage in there would be notes and cautions, rather than the actual steps to do this process, just to make sure that you're aware of the safety procedures and back-out procedures in case something unexpected happens.
added the only other ingredient that I needed, which was an equal amount of concentrated hydrochloric acid. Now, with the flask fully loaded, I got rid of the funnel, and I slid in some glass tubing that was connected to the hydrogen sulfide generator. I then sealed the middle one with a stopper, and into the one on the right, I added another gas outlet. This one would lead to something called an inverted funnel trap, which would hopefully destroy any hydrogen sulfide that made it through the system. The fume hood that I was doing this in should have been more than enough to keep me safe, but I just wanted to be extra careful.
Good bringing up the fume hood and that it has enough flow to flush anything out before it reaches a sufficient concentration or quantity.
So, I just filled this beaker with concentrated sodium hydroxide, and at this point, things were looking pretty good. I then went back to the reaction flask, added a bowl under it, and filled it with water and ice. It was going to take a few minutes to cool down, though, so while I waited, I went back to the gas generator. The last thing that I had to do was fill the addition funnel that was above it, and I just poured in a bunch of dilute hydrochloric acid.
Okay.
I then sealed it with a stopper, but for safety reasons, I didn't clamp it down. This way, if pressure were to somehow build up, this stopper would just pop out instead of the whole setup exploding.
Just like putting in a simple pressure relief valve. So for things this size up to the pressurizer in a nuclear power plant, you need to have something to relieve pressure. It's a key safety tool, and of course, in the case of the nuclear plant, you have several redundant systems that are all rated for different pressures, such as a power-operated relief valve that will go open around 2300 psi, and the safety relief valves that are just spring-loaded that go in at 2485 psi. Phase based on levels of controllability and based on how much the pressure spike is. After all, no need to put a really big hole in your pressurizer if your pressure is just a little high.
But anyway, at this point, it was pretty much good to go, and I was technically ready to start. I was honestly a little bit nervous, but when I eventually felt I was ready for a potential disaster, I carefully opened the addition funnel.
There it goes.
The moment that the acid touched the iron sulfide, it started reacting
Here it comes.
and releasing hydrogen sulfide gas. All of this scary gas was then getting pushed out of the flask and through the tubing and into the reaction flask. It was then bubbling through the acetone and the hydrochloric acid, and honestly, it really didn't look like anything was happening. In theory, though, it was supposed to be reacting with the acetone and turning it into the trithioacetone. This form of it was still apparently really stinky, but it was supposed to be much more tame and easier to handle. The only part that made me a bit paranoid was that technically, thioacetone was being made in this reaction. It was just an intermediate though, and it was supposed to almost immediately combine and turn into the trithioacetone, but still. This meant that if I bubbled the hydrogen sulfide too quickly, it was possible that some thioacetone could get pushed out of the flask. This could then potentially escape my setup and get pulled away by my fume hood.
That was a fun little animation.
And if we're as bad as the stories claimed, it could be a big problem.
Oh, and exhausted out into wherever this lab is, the environment. Yeah, that's one of the key areas you look at in a nuclear plant. Just the unit vent, basically the common header where all of the fume hoods and just about any HVAC system discharges out. And needless to say, there's several redundant radiation monitors, and it has the ability to automatically close if it were to detect a spike. But I don't know. What would you have in this case? Somebody standing on top and smelling it? Smelling the exhaust and then shutting it in case it gets too smelly?
So, the amount of hydrogen sulfide that I was making had to be very carefully controlled. Besides that, though, things were actually looking pretty good, and I basically just had to keep it going until it was done, which was apparently 10 to 12 hours. The only sad part was that I couldn't leave it unattended, and I had to watch it pretty closely the entire time.
Don't have a buddy to tag in and out. There are a lot of operations at a nuclear plant that require constant 24/7 watch, but you just simply have a different watch stander come in and do a turnover.
For the next hour, though, it still kind of looked like nothing was happening, and I started thinking that I might have been wasting my time. However, it then suddenly turned cloudy when I wasn't looking, and I was really happy to see this.
Watch pot never boils.
I then kept it going, and I definitely felt that it was getting cloudier and cloudier. It was only when it hit the 4-hour mark, though, that I really started to get excited. It wasn't super obvious, but it looked like there was a bit of oil that was forming on the surface. This was a really good sign because
subtle.
trithioacetone...
I don't think I would have noticed that unless he pointed it out. Of course, some things might be easier to just see in person than through a camera.
...is supposed to be an oily liquid. Around the same time, though, I also noticed that the generator was running out of iron sulfide, and it was getting a little too full. So to continue, I was going to have to swap out the flask for a fresh one that was full of new iron sulfide. I was also going to have to do this every few hours, and it was far from ideal to say the least.
The equivalent of online refueling, rotisserie style, the way they do them in the CANDU nuclear plants.
With the fresh sulfide, though, I was able to keep it going, and about an hour later, when I slowed down the stirring, I saw something even more exciting. At first, it was hard to see, but there were actually some small blobs of oil that were floating around. Then, after another couple hours, there were a lot more. I was really trying not to get my hopes up, but at this point, things were looking pretty good. So it was, of course, right at this moment that my brother came in and told me that he smelled something.
Yo, it kind of smells bad outside.
Ooh. Is that where it all went?
And this kind of made me panic. So I quickly ran outside
Panic evacuation.
to investigate, and it did smell, but I couldn't figure out where it was coming from, and I figured it was just sewage or garbage or something. But anyway, I then went back to staring at the flask and adjusting
Not gonna check where the fume hood exhausts to.
the bubbling rate, which was honestly getting painful at this point. In the paper, though, it said that it was either 10 to 12 hours or until it stopped absorbing. When I started this reaction, I was really hoping that it would magically stop way earlier, but I never saw any real difference. So, I just ended up going for the full 12 hours. When it was eventually done, though, I felt that it was looking pretty good, and the first thing that I had to do was get rid of the gas line. I was a bit nervous about opening up the flask and unleashing some sort of terror, but it turned out to be totally fine. I was able to just pop it out and replace it with a stopper, and I didn't smell anything. However, I wasn't sure if this was just because my fume hood was working really well, or that I hadn't actually made any trithioacetone. But either way, the next step, according to the paper, was to add a bunch of water to it. So I pulled out the middle stopper, and I started pouring in about 30 mils of cold water. This was supposed to knock out a bunch of the oil, and it definitely looked like it was getting cloudier. I figured this would take some time though, so I resealed the flask, and I let it stir for a while. As it sat there, it seemed to be working, and I was really happy to see some nice drops of oil forming. However, I was also getting a bit concerned, because the paper made it sound like there would be way more. It claimed that there should be as much oil as acetone that I started with, but that definitely wasn't the case. It looked like there was a decent amount, but it was nowhere close to 15 milliliters. Either way, I then took away the stir plate and bowl, and I also got rid of the gas outlet and the trap. What I was left with was a raw reaction mixture, and now, assuming that I'd actually made any trithioacetone, I had to figure out how to get it out. According to the paper, all I had to do was steam distill it, but this was something that kind of concerned. This is because steam distilling this reaction mixture is exactly how they caused that disaster in 1889. Even though I was skeptical of the stories, this still made me a bit hesitant to try it myself. I didn't really have any other good options though, so I decided to just go for it.
Shake it up.
However, at this point, it was already around 2 a.m., so I had to leave it overnight. The next day, I actually woke up feeling pretty confident, but that was almost immediately destroyed the moment that I walked into the room.
Does it smell awful?
I was hit with a really strong sulfur smell, and I kind of panicked that there had been some sort of disaster. When I checked on the flask and the fume hood, though, everything looked totally fine. So, it was nothing catastrophic, but the question now was, where was this mystery smell coming from? Well, apparently, when I touched the flask the day before, an almost invisibly small speck of liquid had gotten onto my glove. I'd then thrown that glove into the garbage, and just that speck was enough to make the whole room reek.
So that's the radiological equivalent of americium dust, where a single invisible particle sticks, smears, and then suddenly every detector in the building is gonna go into alert. Both americium and thioacetone are contamination hazards that really outscale their size by orders of magnitude.
This actually kind of scared me, and I started worrying that all the stories might be true, and that I should absolutely avoid distilling it. However, there was also only one way to find out. So I started setting it up for a distillation, and unfortunately, this meant that I was going to have to touch the flask again. I wasn't super excited to do this, but I figured that it would probably be fine if I just left my glove in the fume hood. But either
Yep, just like when you doff your protective clothing when leaving the radiological controlled area, there's a certain way you take it off, like you put your fingers under the glove to take it off and only touch your other glove with the part of your other hand that was not touching the exterior surface of the glove. Same sort of process for your coveralls, hard hat covers, shoe covers, things of that nature. There's actually a very specific sequence for taking off your protective clothing when you leave a radiological controlled area, including diagrams to make sure nobody forgets. Not to mention there's radiation protection specialists that will help you if need be. But yes, all of the used clothing would go into the contaminated bucket where it will need to be processed and then deconned. In most cases, it's just the equivalent of high-end industrial grade laundry. But there are occasionally stuff that'll get contaminated to the point where you just can't use it.
Either way, with the main part of the setup now in place, I then added a heating mantle and a stir plate, a thermometer, and an addition funnel filled with water. I also added the water cooling to the condenser, and I set up a vial to collect the stuff that boiled over. At this point, it was pretty much good to go, but I still wasn't feeling super confident. I guess I'm ready to start the distillation. There was nothing I could do about that though, so I just switched on the heating, and I nervously waited for it to heat up. It actually ended up going way faster than I thought, and within a few minutes it was already boiling, and I started collecting something in the vial. When I looked at the thermometer though, it was only around 56 degrees Celsius, and this told me that it was just unreacted acetone. This made sense because I didn't expect 100% of it to react, and I assumed I'd recover
You're never going to expect 100% efficiency in any of these sorts of processes.
at least some of it. However, as I kept collecting it, I started getting a bit worried.
There's kind of
It
a lot
just
of it.
didn't seem to stop, and it was slowly creeping towards the amount that I had started with. The reaction clearly didn't go as well as I had thought, but I still had hope. Thankfully, it eventually started slowing down, and the temperature started rising. It then gradually crept up to 100 degrees Celsius, and this was the beginning of the potentially scary part.
Sure.
This was when the trithioacetone was supposed to start vaporizing, and I quickly swapped out the vial. I then waited for something to start coming over, and I was eventually greeted with a nice drop of cloudy liquid. This was actually mostly water, but it was cloudy because the water vapor had carried something oily along with it.
Probably just as well, because you definitely don't want it to be pure. That would be badly concentrated.
In theory, this should be the trithioacetone, and this process of distilling it from boiling water is called a steam distillation. It's basically allowing me to distill it at a much lower temperature, which reduces the risk of the trithioacetone falling apart and ruining my life. But anyway, I then covered the flask to help the water come over, and I just kept collecting it. I also opened the addition funnel, and I slowly added water at roughly the same rate that I was distilling it. Now, going back to the vial, I saw that everything that I'd collected up until now was just a hazy liquid. As I collected more though, it actually cleared up a lot, and I started seeing some nice drops of oil. What I also really liked was that unlike a lot of other oils, which float on water, this one was sitting at the bottom, which told me that it was heavier. This was a very good sign, because trithioacetone is supposed to be slightly denser than water. Eventually, it looked like I was basically just distilling pure water, and I figured that it was probably done. Just to be absolutely sure that I got everything though, I took away this vial and immediately sealed it, and replaced it with a fresh one. I then kept collecting the water, but it didn't look like there was any oil in it.
What's interesting is just certain types of water can actually have a smell, such as tritiated water. Sometimes seen it as H2O, but chemically it's the same as H2O, but just one of them is tritium or hydrogen 3. And that's going to be found in heavy water reactors, such as can-do reactors, which use D2O or H2O with hydrogen 2, deuterium, and it absorbs a neutron because it's in a neutron field because it's an operating nuclear power plant. You can also see stuff like this in fusion experiments. And water itself is odorless, but the smell comes from the decay of tritium. And when it decays, it can create radiolysis products with a faint, ozony, metallic-y smell. It's not nearly as bad as hydrogen sulfide or whatever thioacetone is supposed to smell like, but it's at least noteworthy that you can have smelly water that's still technically water.
So at this point, I considered it done, and I was honestly kind of shocked by how well it had gone. It ended up being way more tame than I thought it would be, and at least as far as I knew, there hadn't been a major disaster. I then went and checked on all the oil
As far as I know, there hasn't been a major disaster. It'd be funny if reactor operators put that on their turnover sheet.
I'd collected before, and it had combined into a really nice blob. It was nowhere near the 15 mils that I was hoping for, but if this were trithioacetone, it was still way more than I needed.
Okay.
It was also probably pretty stinky.
I was gonna say, could always make more.
And I was really curious to know what it smelled like. However, I was also kind of scared to open it outside the fume hood, so I tried just smelling it through the vial.
Gonna crack it open a little bit.
It actually doesn't smell bad at all.
Huh.
It kind of smells like grapefruit candy.
I was honestly extremely surprised by this, and I was also a bit confused
Don't drink
about how something so stinky had become good. So I looked up what it was supposed to smell like,
it. Why does it smell good for some reason?
and I was actually kind of surprised by what I saw. This is because, in very low concentrations,
Odor type fruity.
it can apparently smell tropical with a grapefruit nuance. But anyway, what I had to do next was separate this purified oil from all the water.
Mm-hmm.
So I went and got a pipette, and I carefully tried to suck it all out. I was doing my best to only get the oil,
Sure.
but I also did end up getting a little bit of the water. I then shot it into a much smaller
Some of the water is just good to help it move through the pipette.
vial, and I attempted to get rid of the extra water. It ended up being a bit of a struggle, and I lost some of the oil doing it, but I was able to get rid of pretty much all of it. At this point, things were looking really good, and the only issue was that the oil was slightly cloudy because there was a small amount of water still in it. So, to clear it up, I added some calcium chloride, and I let it sit for a while. About 10 minutes later, it was looking way better, but just for good measure, I added some more calcium chloride. Then after another 30 minutes of waiting, I carefully pulled everything out. What I had now was a bunch of nice and crystal clear oil, and according to the paper, if this were trithioacetone, it should freeze when it's cooled down. So, to test this out, I put it into some ice water, and I let it sit there for a while. Then, when I came back to it about an hour later, I was really happy with what I saw. It had completely solidified, and it had formed some really nice crystals. The moment that I saw this, I was basically 99.5% sure that this was some nice and pure trithioacetone. To be absolutely sure, though,
I thought it was going to be one of those 99.5% sure that there's a 20% chance this might be right, or something like that.
I was going to have to run some tests. So I quickly ran it on my machine that can do something called FTIR.
Okay, that's Fourier transform infrared spectroscopy.
And this was what it gave me.
So it identifies chemical compounds based on how they absorb infrared radiation. Each type of bond vibrates at its characteristic frequency. So you can fingerprint molecules based on this. We do spectroscopy all the times in nuclear engineering, and You can also, using different machines, of course, but identify what type of isotope something is based on the energy of the gamma rays they emit, for instance. Difference is, rather than using IR, you're using ionizing radiation detectors. And in this case, you can spot all of the functional groups, such as carbon-hydrogen, oxygen-hydrogen, carbon-oxygen, for instance. This is a good, quick QA/QC tool.
It was basically a fingerprint of the chemical that I made, and all I had to do next was find a reference one for the trithioacetone.
Sure.
I then did the super complicated and scientific process of just comparing their shapes, and I saw that they were pretty much the same. Then just for good measure, I also did an HNMR on it.
Now HNMR, that is hydrogen nuclear magnetic resonance spectroscopy. We've also seen it as PNMR, proton nuclear magnetic resonance spectroscopy. Because after all, when you look at the nuclear structure, hydrogen, protons, the same thing when dealing with hydrogen 1. And the difference is this one you're looking at nuclear magnetic resonance. This one's going to be more powerful for determining the actual molecular structure. And both of these tools are non-destructive, which is nice.
And I again got exactly what I was looking for.
Boom.
Okay, so now I was 100% sure that I had successfully made the trithioacetone. However, before trying to turn this into the horrible thioacetone, I felt that I had to know what this smelled like in its pure form. It's supposed to only be a fraction of the terribleness, but I had to get at least some sort of idea of what I was dealing with.
A fraction of the terribleness.
I kind of already smell it from here. It's like just sulfury. It reminds me a bit of durian fruit. It just has a nasty
musk,
sulfury, rotten smell. It's not that bad. But now I'll open it and see if my opinion changes.
Oh my. Oh.
Still not that bad. It's what's worse
not
is
great,
just
not terrible.
It permeates out of the vial and just kind of leaves a weird sulfury smell in the area. That's actually worse than its pure form, but it's still not that bad. It's not that bad.
Have you done it so bad?
Maybe NileRed's used to it, and he has a nose that's more calibrated for those type of smells, considering what he does as a chemist.
It's so bad. What do you...
But you smell it from there?
God. Dude, your nose. You don't smell it?
I smell it. It's not that bad.
Oh. That's the nastiest thing I've ever smelled. I'm about to throw up.
No.
Yeah.
Actually?
Yeah. Oh.
In general, I'm pretty resistant to smells, so it didn't bother me that much, but having my friend react like this got me a bit worried. This is because the thioacetone is supposed to be insane compared to this.
Mm-hmm.
So there was no way I was going to be breaking apart the trithioacetone in my fume hood or anywhere near someone who could be assaulted by it. And in my mind, there was only one logical thing to do.
What is it?
I rented an entire island.
That is awesome. All right. Now we're getting into the territory of we're doing certain experiments, so we're having to change the location. There is an entire section of the Code of Federal Regulations that talks about where to situate your nuclear power plant. So this is the equivalent of having to relocate something simply because there's too many people in the area that could be potentially adversely affected. Now, in this case, it's going to be absolute because if the experiment is to whiff the smelly thing, then yeah, it's going to cause all sorts of problems. I'm sure there's, depending on where his lab is, all kinds of local or regional ordinances about stink levels or various experiments or something to that effect.
So I'd be far away from any potential victim. The only downside was that if it were horrible, it would be way harder to get away. but I figured I'd deal with that later. When I eventually got to the island, I took a quick little tour, and I tried to find what I felt would be the best spot to do it.
That's an interesting one. An answer I wasn't fully prepared for. I mean, I guess renting an island is cheaper than adding additional expensive HVAC and filtration systems to your lab.
When I eventually found something that I liked, I went back and got all my supplies, and I started putting together my setup. This was thankfully really easy, and the biggest and most complicated thing that I needed was just the table.
Finding terrain that's flat enough.
That's good.
And besides this, the other main thing was just a lab stand with a small flask attached to it. With all this in place, I was able to get started, and the first thing that I had to do was put on a lab coat and some gloves. This wasn't so much for safety though, and it was just because I really didn't want to get stinky stuff on my hands
I would argue that's a form of safety.
or my clothes. With all my protection in place, I was able to pull out the trithioacetone, which I thought transporting would be a horrible, stinky experience. However, by sealing it in a Nalgene bottle and a larger vial, I was actually able to completely block out the smell,
There you go. Give it some containment buildings.
and it was totally fine. That wasn't the case now, though, because it was time to open the vial, and I was immediately blessed with its wonderful smell.
Yeah, still smells terrible.
I then got a glass pipette,
It
and
didn't
I
go bad.
carefully sucked out a small amount of
Or
it.
did it?
I don't think we need to add very much, like just this.
I ended up getting a bit more than I
It's a cute
expected,
little
though,
flask.
which kind of scared me. So I went back and pulled out most of it, and left behind only a very small amount. Now, with it all loaded,
Minimum usable volume is probably what should be thought when doing something like this.
I quickly resealed the trithioacetone, and there was just one final thing that I needed. It was a vacuum pump, and all I had to do was connect it to the flask. To do this, I just spun around the
That is the nice thing about using a very small amount. None of your equipment is going to have to be that big compared to, say, a vacuum pump that you would use for the main condenser at a nuclear power plant, which would be about 10 times the size of this table. Oh, and you're going to need 3 of them to sufficiently remove the non-condensable gases for the main condenser while it's operating.
adapter to make sure that the grease made a good seal, and that was about it. I then turned it on and started sucking out all the air. After about a minute, I felt that I had a nice vacuum, so I carefully turned the valve to seal the flask. I then turned off the pump and pulled off the rubber hosing, and at this point, I was pretty much good to go. It was now finally time to turn it into the thioacetone, and in theory, all I had to do was heat it up. I
There
was
you go.
honestly a bit scared that I was about to create a disaster,
Lots of confidence.
but again,
Did you warn the buffer zones, the neighboring islands, or wherever it is you went to?
there was only one way to find out. So, when I felt that I was ready, I very nervously started blasting it.
Nervous
The
blasting.
goal here was to just heat it up until it got to at least 500 or 600 C.
Okay.
Boiling.
This is because at that temperature, the trithioacetone was supposed to crack and split apart into the thioacetone. The vacuum was important because it helped keep everything sealed, and it should also prevent the trithioacetone from burning. But anyway, after blasting it for a while, I eventually felt that it had gotten hot enough.
That's definitely at 500 C.
Okay.
Okay. There's a nice vapor in there. I feel scared.
At this point, I felt that things were looking pretty good,
Crack the valve
but the
open.
flask was still really hot, so I had to wait for it to cool down. When I came back to it about 10 minutes later, it was only slightly warm, and I carefully took it off the stand. Now, I guess this was the moment that I was waiting for. and I really didn't know what to expect.
I guess all we need to do is turn it to let the air back in. And open it.
I really thought that I was just going to be assaulted the moment that it was opened, but even when I smelled the flask directly, I didn't notice anything crazy. It smelled pretty much the same as the original trithioacetone, and considering how much I'd been anticipating this moment,
I smell something.
I was kind of disappointed. It was possible that I just had a broken sense of smell or something, though, so I asked my poor friend behind the camera for his opinion.
It does stink.
But is it different than before?
No, smells like before.
Yeah.
Smells the same. It just stinks.
It just
Nothing's changed.
stinks.
So, it didn't seem like I had actually made any thioacetone, and I figured that it was because I hadn't gotten it hot enough. To properly split it apart, I was going to have a bit more courage.
A bit more courage. Gotta add some courage into
and to
the
really
flask.
blast it so that it for sure got to at least 500 degrees Celsius. What was nice was that it still looked like there was a bunch of trithioacetone in the flask.
Plenty of courage.
So I didn't have to reload it. All I had to do was reattach the vacuum pump and suck out the air. Then, about 30 seconds later, I turned off the pump and pulled off the tubing. I was now ready to blast it, and this time I decided to use a real blowtorch, and I would go until I was absolutely sure that it was hot enough.
More vapor this time.
Okay. I think that was hot enough. And it's starting to oh, that's good.
What I
Turning
started
black?
noticing was that it was turning orange at the top.
Oh, orange.
From what I read online,
Oh, yeah, I
this
see it
was
now.
actually a very good sign that thioacetone was forming. This is because thioacetone isn't very stable above negative 20C, so it tends to start polymerizing and turning orange. I was now very confident that I had actually made it, and I was getting pretty excited. What I had to do now
We're
was
scared.
just wait for it to cool down, but I was kind of worried that all the thioacetone would polymerize. So instead, I just pulled the entire thing off the stand, and I did a quick test to see if it smelled.
No.
Then after that, I very nervously opened it up, and I was mentally preparing myself for something horrifying.
Brace.
Oh.
Unlike last time, it actually smelled almost immediately, and it definitely wasn't pleasant, but it also wasn't nearly as bad as I was expecting.
Sure.
I don't know if it's worse.
I then tried smelling the flask directly, but I just didn't feel like it was that bad. This whole time, though, I could hear my friend behind the camera suffering.
Do you smell it?
Yeah, it reeks. It reeks.
Oh, it escapes quickly.
It smells so bad.
I felt bad for him, but I was also very surprised because he was not only far away, he was also slightly upwind. However, I then remembered that there were some claims that thioacetone actually smelled worse when it was less concentrated.
So this is interesting, and it's all kind of dusty. It's kind of like uranium dust. A lump of solid uranium is relatively tame, but if you were to aerosolize it, it becomes more hazardous. And in that case, as paradoxically as it sounds, dilution could seem to increase the effective exposure because the stuff is going to disperse more within the pathways within your body, i.e. your nose, or your mouth for that matter. So it's weird, but it's not necessarily that weird.
So I decided to try holding the flask further away to see if it would make a difference. When it was up close, it had much more of a chemical smell, and it was kind of a slightly rancid version of a natural gas
Rancid
leak.
gas leak, yeah.
Further away, though,
Yeah.
I felt that it was more like garbage mixed with sewage,
Ugh.
and it was definitely a lot worse. However, I still didn't think it was that bad, and I had a hard time believing that this was the chemical responsible for all the stories. I then started thinking, though, that maybe I was just working with way too little of it. All of
Wow, okay. Yeah, that could be it. Also, it was hyped up. I mean, he was probably bracing for something to be worse.
the stories make it sound like this unbelievably terrifying chemical, but at the end of the day, it's just stinky and really potent. To get a big result, it would still need a decent amount of it, and when I went back and read about that disaster in 1889, they
100
were
grams.
apparently working with 100 grams of trithioacetone, which is absolutely insane.
That's a lot.
I didn't have anything even remotely close to that, but I put in most of what I had left,
Okay.
which was probably around 0.25 grams. I also felt that with
Yeah.
a lot more, I didn't need to use a vacuum, and I
I
just
could see 100 grams being a problem.
started blasting it. Just like before, as I heated it, the trithioacetone started fuming, and then it eventually all started boiling. Unlike last time, though, all of the
Got your
vapor
vent
started
path.
slowly turning orange and pouring out of the flask. At this point, though, I still didn't smell anything because the wind was blowing it away from me.
Sure.
However, considering how much of it I was making, I was getting a bit concerned. But anyway, I eventually felt that I had blasted it enough, and it was time to test it out. But let's go down.
Go stand downwind of it.
Oh yeah, you can smell it right here.
Oh, yeah.
It was definitely a lot stronger than the other time, but it was also kind of the same thing, and I just didn't think that it smelled that bad. One thing that I hadn't tested yet, though, was how far the smell could travel. I'm gonna go deeper in the forest. This was something that was a big part of all the stories, so I tried going a bit further away. However, I quickly realized that I was probably the worst person to be doing this test, because I clearly wasn't very sensitive to it. Yeah, I think I can still smell it, but it's not that bad. So I asked my friend behind the camera for one final sacrifice. Up until now,
He's the control group.
the wind had been strong enough that he hadn't smelled anything, but that unfortunately changed for him when he got closer to the flask.
Oh,
Oh, he's not appreciating that too much.
stinks.
What on 10? What is it now?
Like 10 on 10.
10 on 10.
He was clearly a lot more sensitive to it than I
Sure.
was,
Oh, disgusting.
and it seemed to get even worse for him as he got further away.
Oh, when does it stop?
It doesn't.
Oh, no.
I honestly thought this was kind of funny, but then it looked like he was actually getting worried.
Dude, it still stinks. We gotta stop this.
You gotta
It
stop
then
this.
continued to get worse,
Oh, it gets stronger right here.
and I still wasn't really concerned until he got to the water.
Oh, it's gonna travel across the It's gonna travel across the lake.
Man, uh-oh.
I had honestly rented this island mostly because I thought it would be funny for the video, and I didn't actually think the smell would travel this much. However, we weren't exactly in the middle of nowhere.
Ooh, yeah.
There were still a bunch of houses, only a couple hundred meters downwind, and I was
Wow, okay. Time to commence evacuation.
genuinely starting to get worried.
Kind of concerned that, like, somebody might call 911.
It stinks.
Besides its horrible ability to travel, though, I was also starting to realize one of the other big issues with thioacetone.
It doesn't smell like
Yeah.
it's coming from anywhere.
No, it's 360-degree smell.
I mean, kind of like a neutron field in a reactor hull. Radiation doesn't beam from one direction. It's going to be omnidirectional in that particular environment. No clear line of sight, no obvious source. You just know you're immersed in it. And as far as the renting an island goes, it's the equivalent of doing all the nuclear testing out in Los Alamos, out in the middle of the desert. You're isolated, but unfortunately, atmospheric transport does not respect property lines. It's a shame.
There was no clear direction that it was coming from, and I could see how this could be very overwhelming. Also, without knowing the source, I could see how someone could interpret it as a gas leak or something else dangerous. It also seemed to really stick around, and even after several minutes...
How close are you to a chemical plant?
It was still really unpleasant.
Shut it down.
Shut it down. Turn it off. There was no way to shut it down. Yeah. Open to the environment.
He's angry too.
The birds?
Eventually, though, the smell
that?
seemed to mostly go away, and at this point, I was done making the thioacetone. However, I was still somewhat concerned that someone would call the police, and I really didn't want to have to try and explain what I was doing. So I quickly dismantled my little forest chemistry setup, and I packed it all in my car. I then transported all of the horribly stinky stuff back home.
I love the implication that he drove his car through the water. I know I saw the canoe, but that's funny.
And it was a somewhat unpleasant 2-hour drive.
2 hours of...
But anyway, in the end...
2 hours of hotboxing thioacetone.
I had successfully made the mythical thioacetone, and I'm very happy that I got to personally experience its horribleness. It wasn't quite as overwhelmingly bad as I was hoping it would be, but it made up for that by being almost unbelievably potent.
Go ahead and make 100 grams of the stuff.
And I was genuinely surprised by how far it could travel. I can totally see how a relatively small amount of it could terrorize an entire town, and on that scale, I wouldn't be surprised if at least a few people vomited or passed out. So for the most part, I think that it's pretty much as bad as it's claimed to be, and it's almost definitely one of the worst smelling chemicals ever made. In the future, I might try making some other smelly chemicals, but for now, I think I'm going to take a break from the stinky stuff.
Yes, trioacetone is to chemists what strontium-90 or americium dust is to nuclear engineers. Not dramatic on the surface, but the potential to be quite potent in trace amounts and making life miserable for communities. Thanks so much for the recommendation, and thanks so much for watching. I'll see you next time.